So do audience tend to ask a question in this workshop so far?
You mean the participants can, whether the participant can ask a question for our
No,
panelists?
I'm just saying whether they actually ask question or not.
So for our paper presentation, we encourage them to ask a question in the page chat. But personally, I experienced the technical difficulty. I couldn't type anything in the page chat. And the way to resolve it is to log out and re-log in. It may recover. Yeah.
Yeah,
so
I think we are live now.
Yeah, I think our panel starts now. I can see the countdown of the time. Yeah, so welcome to the panel, our ICSI workshop on cloud intelligence. The topic of this panel is how to accelerate collaboration on cloud intelligence across academia and the industry. So today we are happy to have invited 5 panelists to attend our panel. I myself is the organizer of this panel. My name is Xin Peng from Fudan University in China. And we have 5 panelists here. The first one is Professor Shan Lu from University of Chicago. And the second is Ode Kao, Professor Ode Kao from the Technical University of Berlin. And the third panelist is Professor Hongyu Zhang from the University of Newcastle. And the fourth panelist is Professor Dan Pei from Tsinghua University, China. The fifth panelist is Rajita Banwan. She is from Microservice Research, India. So for today's panel, we have 4 questions. So for each question, the panelists can talk about the questions. So after each panelist has presented their opinions, we can have some small discussion if we have some further comments on the others' opinions. And we know that the topic of this panel is about the collaboration between industry and academia. So we can see that we have 1 panelist from Microsoft. The other 4 are all from academia. But I think all of the 4 professors had very rich experience in collaborating with the industry. So I think even they are from academia, they know, they understand the status, and also they have their ideas of how about the topic of today's panel, that is how to accelerate the collaboration between industry and academia on cloud intelligence. So let's enter the first question. How do you understand cloud intelligence? Can you describe your background and experience on cloud intelligence? So first, Professor Shan Lu, can you share your experience?
Okay. Yeah. So first of all, I'm very glad to have this opportunity. My main research background and interest is about software correctness, software efficiency, about how to build tools to help developers write better code. So then, in terms of what's my experience on cloud intelligence. So in the last few years, me and my collaborator were working on several aspects. One still about how to help developer. So for example, we are looking at how developers use cloud intelligence in their own software. So like there are a lot of cloud machine learning services. Then when developers use these services in their own software, when they try to integrate, right, that can potentially be correctness problem and efficiency problem. The other aspect is still from to develop how to develop better tools for software. From that perspective, we're looking at like just in general cloud software, and today's cloud software is very complicated, and we found out the intelligence, right, these no matter machine learning or some this technique, they can actually help traditional program analysis, and that can help goes back to help analyze and improve the quality of cloud framework infrastructure. And the last aspect is, and I think there are many people working on this, like for example, how to do better resource management in the cloud setting, because now a lot of cloud data centers, they're hosting, this machine learning component and traditional component, and how to better coordinate them. Yeah, so that's my background and experience.
Okay, thanks, Professor Shanlu. So, Professor Odikal, can you share your experience for the first question?
Yes, thank you very much first for inviting me to this wonderful workshop and also giving my PhD students this opportunity to present our work. Yes, my name is Odekal from the Berlin University of Technology in Berlin, Germany. And yeah, I'm a computer scientist by training, and my primary field is resource management. Started with cluster computing, then grid computing, cloud computing. And at some point of time, I switched to big data because it was really interesting to see how we can do resource management in these big data engines. And we also co-developed Flink, which is now one of the major big data engines out there. And then it was interesting to see how I can connect big data with something that I'm doing on the second part of my job, which is mainly building huge infrastructure. So I built several data centers and manage this in a day-to-day fashion. And of course, you see once you're in a data center that the requirements are getting bigger day by day. It's not just availability, it's also security, many new users and functions and so on. And the idea was how to combine kind of machine learning and big data to help these people to manage the infrastructures much better. I got into the field of AIOps by push of a large Chinese cloud provider who also has a research center in Munich. And they came to us, and of course, every large company wants to benefit from the virtualization and network function virtualization and so on. There's a huge benefit in applying these functions. On the other hand, there's of course, it's much less reliable than if you take dedicated servers. So the idea was how to provide to get up to the same reliability of the systems for telecommunications, for example, by applying some interesting machine learning operators. And we started first very straightforward with metric data, try to analyze the systems. That's a good part on AIOps is you have plenty of data. That's something we never saw in the big data field, but here you have a huge amount of data, which is great for us. But then we got great results, and then we went to China and tried these methods in the production cloud centers, and what seemed to be a great development in academia turned out to be okay. So our measured rates dropped significantly once you go into the real environment. So there's some noise, there are updates, there are upgrades, there are different systems. So and this took us more into the area we need to collaborate with companies. And for the first, and the second was, and I liked very much the picture that my colleague Dan Pei showed in his keynote talk with this elephant, and exactly what we try to do. So you go first with the metric data, then you go and look in the tracing data, you look at microservices architectures, you look at logs, and we try somehow to connect all these results into something that makes sense on a higher level. And of course, you probably heard several of the talks from my group today, and I don't want to bother you with the details of this research, but currently we are working mainly in the log analytics and on the microservices. That's our major fields.
Okay, thank you. So next one, Hongyu, can you share your experience?
Yeah, my name is Hongyu. So basically, my research area is about intelligent software engineering, data-driven software engineering, and software analytics. Yeah, so as for the question, how do you understand the cloud intelligence? Yeah, so basically, I think cloud assistants, like traditional software assistants, should have high quality. So there are many software quality attributes like reliability, availability, performance, resiliency, security, capacity, and so on. So basically, they are all key quality attributes for a cloud system. So right now, a lot of effort has been spent on the quality assurance, but in reality, cloud systems still suffer from incidents. So we can apply all kinds of AI techniques and machine learning techniques, data mining techniques to analyze the data produced from the operations of the cloud systems. And then we can develop machine learning based models to improve the quality of the cloud systems. So in this area, I worked with Microsoft Research Asia on many topics. So basically, we analyze log data and metric data of cloud systems and proposed many log-based fault detection techniques. We also analyzed these issue reports and incident reports and proposed many incident management techniques to better manage the incidents of cloud systems. Yeah, so I think this is an interesting field. So yeah, it's good to further work on it. Yeah, thank you.
Okay, thank you, Hongyu. So next one, Dan, can you share your experience?
Yeah. First
Okay.
of all, thanks for inviting me for attending this panel. I myself actually spent 6 years in industry at AT&T Research in New Jersey, USA. So I have experience collaborating from industry with the university professor, and then after I came back to China, I work at Tsinghua University. I work with industry collaborators as well. So I kind of have experience on both. So I have some really like this topic of this panel, and in my opinion, so of course, cloud make it much easier for application developer to make their application service more reliable, having higher performance, and improve efficiency and security. So in my opinion, cloud intelligence can provide benefit to all the perspective that cloud provides to tenants. Right. So, I came from the networking community. I'd like to take a system perspective. So, in my opinion, cloud intelligence essentially just in addition to traditional method, we have some components of the entire system upgraded to some AI-enabled components to implement something that previously may not be possible. But still, it's just those are just upgrade to the component. We still need this entire system architecture to integrate all kinds of approaches, including AI-enabled approaches. So in the past like 10 years, I have been working on quite some aspect of the cloud intelligence problem, and have been using data, knowledge, algorithm, and these things to come up with solutions. And in particular, I have been focusing on anomaly detection, root cause analysis, failure prediction, etc. So that's my background. Thank you.
Okay, thank you. So the last one, Ranjita, can you share your experience?
Yeah, sure. So I've been working applying machine learning and other data-driven techniques to systems and networking for maybe around 12 or 13 years now. But it's really in the last 6 or 7 years that this whole space has really heated up. And there are two reasons, the way I see it, there are two reasons why this has happened. The first one is that is the whole principle of continuous integration, continuous deployment, right? So earlier, when you would buy software as CDs, let's say, take the example of Windows, you bought one version of Windows, you put it on your computer, and then you didn't upgrade, or you didn't do this for the next 1 or 2 years at least. Now, on the other hand, when all this software is cloud-based, you see deployments, sometimes multiple deployments in a single day. And what that means is that there is inherent similarity between these deployments. And that implies that you can apply more machine learning techniques to inform future deployments from past deployments. The similarity is there, which wasn't there earlier. So that's one. The second is because all of these instances of the service are running in the cloud, the service provider can actually collect rich telemetry on how this service is running. So for instance, Office 365 collects petabytes of telemetry in just a single day. It's huge. And that gives more opportunities. So now a pipeline which had, the software development pipeline used to be develop the software, deploy the software, and monitor. Now you have another stage, which is learn and feedback into all of these stages. So that to me is what cloud intelligence is and why it's become super important in the last few years. And it's going to get even more important going forward. And my experience specifically in the last 5 or 6 years has been working with Office 365. And I've worked with Office 365 on various problems, such as using the data on their development systems to inform their developers better on finding bugs, root causing systems, shifting left. So that we worked on a project called Sankey, which did that. And there are papers on this in software engineering venues and systems venues. More recently, over the last 2 years, I'm working with them on improving their efficiency, resource efficiency, with, say, wide area networking provisioning and also system provisioning. So that's my background. Thanks.
Okay, thank you. Thank all the 5 panelists. So we finished the first question. So we all know something about each other, about the experience, and also the domains that each one works on. So to the second question. What's the status of the research and the practice of cloud intelligence in academia and the industry? What's the maturity of different parts of cloud intelligence techniques? How do cloud intelligence techniques apply in industry? So this question is very broad. I think so. I think each panelist can just talk something that you are most familiar with. Okay. So still, Professor Lushan, can you be the first one to share your experience? Opinions.
Sure. Yeah. I think this is a very broad question, and so I think just from related to the area that I'm working on, software reliability, efficiency. I feel like there are a lot of people working on applying machine learning for software, and improving the software for machine learning. So which is great, and I see a lot of exciting work at ICSE. I feel like if say something that are still not that mature, or what I think that need more work on, I feel like each component, like for example, it's just for DNN, like for neural network itself. For example, there have been a lot of research. Just to improve, say, the training and the inference efficiency of the machine learning component itself, and also, for example, say testing. There's also a lot of work from both software engineering community and security community. But I feel like I feel like what is lacking is to look at the integration, like looking at how a software that contain both traditional code and the intelligent part, and when we look them as together, how to reason about the performance, what's the new performance model, what will be the how to do the correctness guarantee, how to do the reasoning or even proof, considering both the traditional coding and the intelligent part altogether. So I feel like that is the part that is, there's still a lot of open questions. And then another thing is, which is, there have been a lot of work, but still there's a long way to go, which is, I think Hongyu also mentioned this, like the overall, the service reliability. There's still a lot of, there are tons of incidents in the cloud framework, and in the cloud service that is offering that intelligence. And I think this is something that people have worked on this for many years, but unfortunately, just because today's cloud become much more heterogeneous, And also no matter the software architecture and the hardware platform and the workload has all become much more complicated. There are many different layers. There are also many different types of workload. So because of that, I think there are just many. The problem is just become more diverse, and the code itself is more complicated to analyze. So I think just in general for that part, I think there's still a lot of work to work on. But of course, there are more resources. Like I think Ranjita mentioned that there are a lot of telemetric data. There are a lot of data to analyze. The question is how to analyze the data to improve the reliability of our cloud service. Okay, yeah, so this is my take.
Okay, so thank you. Next one, Professor Odenkow, can you share your experience on the second question?
Yes, I try. So maybe first of all, industry is very hard to define. So what I see from my point of view is a huge gap. So they're the usual suspects. And we have some of them on board here. They have, of course, great systems and have put a lot of work. But if you go out there in the field, there's not much left to see. And I don't know why. Maybe we are too early. Maybe our methods are still not enough. But maybe there is some kind of acceptance problem from the other side, which we are facing frequently. If you talk to SREs and NREs, they are still kind of doubting, this is something that assists me and helps in my daily work, or is this something that's going to replace me? And depending on the answer that each of these individuals is giving to herself, there are different acceptances of what we are doing. So what I face right now is that I don't see much industry around. I see a lot of research centers. So in my last 6 years in AI Ops here, we talked a little bit with the production departments, but the most talks were with the research departments of the large companies. So they're putting tremendous efforts in this area, but they suffer sometimes with the same problems that we do. So they don't have the real data, so they have to make up data somehow. They are not the people who are doing day-by-day work, so they also need help from production departments to get a data labeled, to get some insights how the real-world scenarios are. And maybe the biggest problem, they do not have the holistic image. So what we see is that we get sometimes assignments like, we have this particular problem, and could you see if we can solve this particular problem? But AIOps as a whole new way of doing operation or developing software is still not there, at least not to a larger extent. So therefore, I think we need to define very closely what industry is. And what we're doing right now is great for the large companies, but I believe it's maybe a little bit overkill for the smaller companies. Thank you very much.
Okay, thank you. So Hongyu?
Yeah, I think all of us here have developed some kinds of cloud intelligence techniques and also apply them to industry. So I think we all have some stories to share. And I also know that Microsoft Research Asia teams have also applied many advanced AI-based techniques to improve the reliability and availability of many cloud systems like Microsoft Azure, Microsoft Office 365, and OneDrive, and so on. Yeah, so they also have many success stories and lessons learned. So as for the matured techniques, I think this fault detection could be one of the matured techniques in cloud intelligence. Yeah, so basically, as we know, many people propose the log-based anomaly detections and the metric-based fault detection methods. So these techniques has been there for more than 10 years, I think. So these techniques are quite matured. And also techniques for incident management are quite matured too. So basically, for cloud systems, we may receive a large number of issue reports, incident reports. So we could apply all kinds of information retrieval techniques, deep learning techniques to improve the management of these incident reports. For example, duplicate incident report detection, incident fixed time prediction, incident triage, and so on. Yeah, so basically, I think techniques for incident management are quite matured. So this could be applied to industry. Yeah, okay, let's give some examples.
Yeah, thank you, Hongyu. So you mentioned several very concrete techniques about the cloud intelligence, and it reminded me that most of the technique you mentioned just has their corresponding part in the traditional software development. Yeah, because the bug report maybe is similar to. Yeah. Okay, so Dan.
Yeah. For the sake of time, I will just focus on the second part of your second question, the maturity of different parts of cloud intelligence techniques. I would like to offer some complementary view. In China, I'm working with large internet companies, but also some startups which provide some AIOps technologies to large enterprise customers. And to me, that it seems that there's a pattern that for those techniques that require less data, currently found more success. Well, is intuitive, right? Because for those techniques that need to correlate multiple type of data sources, and you need some like topology data or metadata to correlate them, right? So if you need more such complex dependency data, then it's more challenging to actually have that data in a particular enterprise. But right now, what I found is that for those, for example, time series anomaly detection is real. There's existing technique over there. It's just using AIOps is just an upgrade of the existing technique. Input output are the same. It's just that you can use AIOps to do it better. And I found those techniques are more mature and got more acceptable and is deployed. At least I know in China, other than those large internet company and the cloud providers, and in those traditional enterprises such as banking, telecom, they were, I think there are dozens of deployment of such techniques. Just one particular complementary perspective to the panel. Okay, thanks.
Okay, thank you. So Ranjita?
I can't agree more with what has already been said on this panel in terms of what are important problems in this space. And yes, I'd also like to give a shout out to the work done at Microsoft Research Asia by Qing Wei and his team, some of it with collaboration, I think, with Professor Hongyu. And they've made a big difference to reliability, predictability, anomaly detection, etc. in Microsoft services. But I'd like to talk about a couple of orthogonal problems, which are really big challenges, I think, going forward. One of them is, the first one is really because all of these cloud services are seeing explosive growth, right? So our developers and our software designers are really, really fighting to catch up. And as a result of that, the telemetry systems that exist across these platforms and services are, sometimes rather unstructured. The data is not as structured as you would like. So now, when you have a telemetry system which is getting petabytes of data every day, but lacks structure, how do you actually analyze all of this data, where some of it could be really dirty or they're completely out of sync with each other? So you have to think of building an abstraction layer which allows us as data scientists or people who are doing machine learning for systems to forget about all this dirtiness in the underlying layer. The database folks have done data cleaning for decades. But I think this is a new kind of data cleaning that we need to do. So that, I think, is a significant challenge going forward. The other challenge is that because of this explosive growth, people are looking at individual components and solving problems for those individual components. And that is super important, and that is the first thing to do. But now that we have achieved that, I think we need to take a holistic look at the whole system, starting with the application layers, down to the service that's running, and then to the infrastructure, and finally even to the hardware. Because most of these cloud vendors are now investing in owning pretty much this entire stack, all the way from the application to the hardware. We've got to think holistically on how to apply data-driven techniques to this whole thing. So I'd say those two are major challenges going forward.
Okay, thank you. So I think most of us agree that there's a gap between the research and the practice. And according to my own understanding, I think cloud intelligence or AIOps is a very hot topic in industry, in both industry and academia. But I think it's still in the early stage, so we have a lot of things to do, and also we need to collaborate more with the industry. To the third question, what are the differences between the academia and the industry on cloud intelligence research in terms of research focus and the method? How can they benefit each other? Because we know that even in industry, especially for those big companies, they have also researchers, just like those researchers in microservice. They will also do some research on cloud intelligence or AIOps. And what's the differences between these two kinds of research? One is the research from the academia, the other is the research from industry. How can they benefit each other? So still, Professor Lucia, can you be the first one? Yeah.
Yeah. So first of all, I would just say from our academia's perspective, I always feel like we are lacking something, right? Comparing with our industry friends, I feel like we do not have as much access to industrial data, and we do not have as much, resources. Like for example, when my student says, "Hey, I don't have enough GPU machine to run the training," like we say, "Hey," she said, "Oh, it will take more than 1 year for me to finish all the experiment," and I wish I was in an industry, and also the data. Like for my own research, we look at software bugs. And earlier in my career, I always wish that, every paper, so we have a lot of, paper on checking, open source software bugs. And there's always reviewers saying, "Hey, what about commercial software?" And I always feel like I wish I have access to commercial software. But then on the other side, so in the last few years, I have been doing collaboration with Microsoft, mainly the RISE team in Redmond. And that helped me to get, understanding of, my industry friends. So I feel like my, industry, particularly researcher friends, that's my understanding. I think comparing with them, we have the luxury of, I have a lot of PhD students helping me. And also I feel like we have, on my side, I have the freedom, of branching out or even completely change my direction with the help of my academia, department, my academia friends. And then something, again, going back, some lessons that I've had is like, for example, in the past, there was a period of time that I was looking at cloud, trying to, detect bugs from cloud software. And I was just completely looking at open source software, and we have published a series of papers, at PLDI, ASP+, all the good conferences. And then after all this, I start talking with my industry friend, and then they told me saying, "Well, your technique won't work in our, commercial, real cloud software, because our software is very complicated. Your analysis will not work." I didn't believe them. So I asked one of my PhD students to do an internship. And then it's like in 2 weeks, we realized our technique does not work. And then, of course, the good thing is because of my Microsoft collaborators, and then we together come up with some new technique, and that turns out to be work really well. And that was a paper that we got SSP Best Paper, and that really it really helped me to realize. I mean, there's this difference, and I think it's good to keep this collaboration, or even just to keep the conversation going on. And I think being in academia, we have the student helping us, and we can freely explore different techniques. And some technique may not work now, right? But maybe it will work later. But at the same time, it's good to know what actually is needed by the industry. And also after that, I sent many of my students, go to Microsoft to try to learn, like including the incidents. And I realized that, the real incidents now in the cloud, actually it's different, about different, truly, from, what we can see from the open source community. But at the same time, I also have some, for example, we did some research, for example, looking at, say, web application, and some of those studies, it's like there are industry, but there's no big industry like Microsoft, Facebook, Google. So some of the work we did, and then later on inspired a lot of startup company to look at this. So I feel like, yeah, there is a difference, and it will really, we can benefit each other through collaboration.
Okay, thank you. Oleg, can you share your opinions?
Yes, it's a lot of is already said. Again, what we see is, first, we are not collaborating with industry, but with the research centers of the industry. So these are people just like us, so they are not really production people. So it's not that a huge difference. And in our group, we try to guess, as already said, so what might be needed, and you basically start from the methods. There's big data, there's cloud computing, there's machine learning, and let's see how we can combine this, how we can improve this to solve some problem. But basically, you're working in the dark because you cannot simply try it out. You can try it in the lab, and that's much easier. But then the statement that we just heard from Shanlu, it's the same. It won't work. It won't work. It won't work. So it's sometimes frustrating, and sometimes, of course, they are right, but you never have a chance to get hands-on and to see, to stand next to it and to see and to improve it. That's our problem, and maybe this is the different approach from. We are starting top-down, so you try to start with a big method and then to refine it. And what we get from the companies is frequently bottom up. So we had these problems like, can you predict what will fail? Or we have problem with this server. Could you please see if you can solve this? Here's some data. So it's more of very focused problems, which is very nice, because then at least you get real results and you get the real support for this. But therefore, I believe that the right way to go is exactly to combine the strengths of the two approaches. We need to meet in the middle, and I think that the next question is exactly about this. So what should we do to bring industry and academia together? And I think it's really necessary if we want to progress in this way. Companies cannot afford much research because they have day-by-day work, and we cannot make the decisive progress if we don't get to the machines. And therefore, many of us are going to companies or going to internships, create their own companies, and so just to overcome this gap. Thank you.
Okay, thank you. Hongyu?
Yeah, like what Shan and Oleg just said. So basically, industry has good computing resources. They may have a large scale cloud systems, and they also have a lot of software data, system data, which can be analyzed. So I think the industry has good advantages on that. Also, industry knows the problem very well, so they actually know what are the real problems in their systems. So what could be the possible solutions. So yeah, so these are good for industry, but for university professors, it's difficult for us to construct a large-scale, complex cloud systems. It's difficult for us to replicate other people's study and perform the evaluations within the university environment. So this is our disadvantage, I think. But we also have flexibility. Yeah, as what Shan just mentioned, yeah, we are free. So basically we can propose new ideas or even risky ideas, which are not constrained by the existing environment, existing industrial environment, industrial projects. So when we work on some new problems, future research problems that may not be even feasible in current industrial setting. So we have some freedom. So maybe that's also our advantage. Yeah. So we, as what the previous two panel members said, so industry and academia could work together, can bring us together, and we can complement each other. So we hope that we can have more collaborations in the future.
Okay. So Dan, can you share your opinion?
Yeah, I have some opinion on this, and but my opinion are actually for both questions 3 and 4. I can wait for question 4 to provide my entire opinion altogether and get more time over there. Okay. Is that okay?
Okay, that's fine. Yeah. So Ranjita, can you share your opinion?
On this one, I think pretty much everything has been said. I'd just like to say that I don't think there are that many differences anymore between the research in academia and industry on cloud intelligence. And that is because, just like everybody in this panel, most of this work is coming out of collaboration between industry and academia. So I wonder if anybody has a lot of time, they can actually go and look at the papers in the field, which are purely industry authors, purely academia authors, and collaborations, right? So I would say a big chunk would be through these collaborations. So I really don't, even if there are differences, I think they're converging. Like how Hongyu said, academia has the benefit of having the freedom and also grad students, right? I mean, they're a great resource to have, which industry unfortunately doesn't. And in most groups in industry, the product groups especially, you're always trying to fight fires and solve the most immediate problem first. So that's where academia comes in and looks into this with a much longer term and longer time frame in mind. And so collaboration is the best way forward, I think. Yeah.
Yes. Yeah, I think for academia, I think the one benefit is that we have a maybe broader view of the whole domain, and also I think we are more experienced in abstracting some common techniques from those specific cases. Yeah, and also as you mentioned that the company has the data. I think at least in China, I think academia has more and more opportunities of collaborating with the company. But now I find that maybe there's one issue, one difficulty with this kind of collaboration, that I found that for some very big companies, there's because for those big companies, it have many different departments. So each department only manages a small part of the. For example, in one of the ongoing collaboration with the company, our industry partners show us some data. but we found that maybe the quality of the data is quite bad. But they told us, oh, that the data is not from themselves, but maybe it's from some other department. They cannot manage. They cannot. They can only get the data, but they cannot manage the data. So something like this. So maybe I think, and also before our industry partners begin to collaborate with us, they do not fully understand the possible solution or techniques about it. So maybe after our collaboration starts, we find that maybe their data does not satisfy the assumptions of our approach, something like this. So I think is very common for us that after we sign the contract, start the collaboration. We start to adapt our initial research plan and or even the technique, the design of our solutions. Yeah, I think it's quite that is from my own experience. Yeah. The last question, and the last question. In the third question, we talked about some differences between the academia and the industry, and also how we can benefit each other. So in the last question, maybe we can try to imagine something that we can do to improve the current situation, how we can do it better, how we can accelerate the collaboration on cloud intelligence, across the academia and the industry. And still, Professor Lu Xian, can you share your opinions?
Sure. Yeah, so I guess I would just say I guess from industry side and academia side. From industry side, I cannot say much, but I would just say, like, for example, as I said, in the last few years, have been collaborating with the RISE group from Microsoft Research, and have really enjoyed that collaboration. And I don't know, I don't have much experience of other companies, but yeah, I just feel like, you know, we get access to a lot of data. And I think maybe just like Ranjita was saying, I think things are getting better comparing with like when I was a PhD student. At that time, it was really hard to get industry data. Particularly, I feel like, I don't know about China, in United States, that was my experience. And in the last few years, it was much, I mean, with my collaborators' help, we get to see a lot of, you know, data, real, you know, incidents in the cloud, and we get a lot of suggestion from them about, you know, what are, you know, things that are cared about by industry. So I really enjoyed that collaboration, and I feel like if all the industry have that kind of openness, and that will be fantastic. On our side, I would say that actually I told, like, when Xin, when you were saying, you know, this, like, you look at the things are very different after you sign the contract. Very quickly you find out that it's different. We also experienced that, and we also experienced things like, oh, we get this data, but then when we want to dig in, it turns out they're saying, oh no, we only own this data, and if you want to know what happens, we have to ask another product team, and another product has to ask another product team, which then become impossible. And of course, I think that's hard to change, you know, from industry side. But my suggestion for my, you know, academia friends would be, I think we need to be, you need to be well prepared when you're going into the collaboration. We need to anticipate a lot of challenges. There are data that may be hard to interpret, and also another challenge is, I think is sometimes you may work on something and you may solve a problem, but we may realize the solution is hard to generalize. And because it's hard to generalize beyond that particular company's particular problem, you may find out that it's hard to write a paper about, you know, what you just did. And I think that, unfortunately, it is a challenge for us because we have PhD students who need to graduate, right? I don't really have a solution. I mean, for me, I feel like the experience I learned, you know, the kind of the vision I learned from my industry collaborator, to me that means much more than 1 or 2 paper, right, that I can publish. So I think I feel like we should all have, I hope, right, I think to get better, collaboration experience from the academia side, I think we need to have this mentality. Otherwise, if we say, oh, yes, I want to do collaboration and I want to publish a lot of paper from that collaboration, then I think it's unlikely that the collaboration can go long. Okay, that's my take.
Yes. Yeah. According to my own experience, the companies, when they talk about the collaboration with us, more and more of them will say that, oh, let me include in the publication, paper publication in our contract as one of those those fruits. But fortunately, most of them agree that the industry track is acceptable. So this makes things easier. Yeah. So Oleg, so what's your opinion?
Maybe twofold. So first, we didn't have this experience. You probably know we have this joint Berlin Huawei research labs, and we are just lucky that we have such great partners on board. But the 2 parts that are very important for us, first of all, it's a long-term, at least for us, long-term contract of 4 years. And publication is just necessary, and that's great. So if you find a company giving you a 4 years contract, it's something which is expected for a PhD student. And of course, we are adjusting our research program every 6 months jointly, so you can react to new trends. But on the other hand, you don't need to start all over again with a new contract. So this is something that I can really recommend. And again, Huawei is just a great partner for us. That's the first part, the local part. The second part is how to benefit, how to improve. I don't think that's a improvement of collaboration, academia and industry. I think what we lack is improvement of our own collaboration. So regardless, are you from academia or are you from industry? If you look in other communities like databases or parallel computing, where I spent some time, they have their own conferences, they have their own benchmarking data, they have they meet more frequently, they know each other much better, and so on. And we are not community yet. So there are some superstars. You see the talks and you read the papers, but there is nothing where we meet frequently. So this is one of the rare occasions where you really get with your colleagues on some. Usually we are spread among several conferences, several workshops, and this is something that we need to improve. And where I would start is first to define what is AIOps, what is cloud intelligence, is some kind of definition. Then we need to design a series of workshops and to get us to a joint conference. We need to decide, like Dan Pei has done this with his homepage, some starting reading materials for every PhD student. So if you start in this area, here's a selection of papers. Please read first before you come talking to me. Then we need maybe some data repositories where we can share our data. It doesn't have to be always the industry data, but some good data. So we can improve our methods. We can compare our methods with the other groups. We can verify results, and we can benefit also for our own research. And therefore, I think before we start talking to company, we should build our own community. That would be the priority number 1 for me, and I'm very happy to help doing this. Thank you.
Okay, thank you. Hongyu?
Yeah, for this question, I will make it short so that Dan will have more time to talk. Yeah, so basically, I think it's good that the industry could provide us public benchmark, public data sets, so that we can all evaluate and compare different techniques. So in this way, we could push the research in this field forward. Yeah, okay, so that's what I want to say.
Thank you. So, yeah, Dan?
All right. So as I mentioned, I work in both industry and academia. And when I worked in industry, I collaborate with more than a dozen of university professors. When I work in the academia, I work with directly or indirectly more than I don't know, maybe 30 different industry partners. So I have kind of some experience. I'm gonna, in the end of my opinion speaking, I'm gonna call for a specific community effort. But to summarize, academia need research problem, data, domain knowledge, computation power, and the industry people, other than those research labs, need the problem definition, algorithm, research experience, and student. Right. So back in 2017, because I'm working with in university with multiple industry collaborators, I got a little bit frustrated. I felt that the progress in AIOps is so slow compared to computer vision. When they have standardized problem, a common data set, more people can be attracted and work on the solution altogether. They are creating an ecosystem, and we are not. Okay, so I said, okay, I want to do something. I got inspired by ImageNet. I said, okay, I'm going to start with algorithm competition, right, to solve a problem of what, right? So previously, academia people, industry people, they having some collaboration, but those collaboration are pairwise. And because I'm having multiple collaboration, multiple industry people, I'm repeating all my dirty work of cleaning the data and set up the collaboration multiple times. This is not going to be sustainable. It's not going to be scalable. So as I create a competition, I create a forum so that bring together industry people and academia people so that they can work together. So how? I define a few research problem and talk to the industry people, say, okay, here's a problem. We need this data. If you want to work with me, with this forum, okay, give the data to us. And we are going to call university professors to work on this research problem as an algorithm competition. Okay, so and we define a few problems, maybe a dozen of a different problem, and then got 4 different algorithm competition already, and won very well. Every year we have I don't know, more than 200 teams to participate, and in the end the algorithm end up with were pretty good, but still it's not enough. I found what is so slow, because every year I can only set up 1 algorithm competition, right? So what I'm saying is that I'm going to call for a very specific community effort, because both industry and academia have this interest. Can the industry people, like they are donating infrastructure software, can they, together with the academia people, create AIOps experiment platform as a service? What I mean is that donate real system, real traffic, of course, after cleaning, real failure patterns, real chaos engineering tool, inject real data and get real monitoring data, and then define all those standardized AIOps component, right? And then all those researchers can just work on those research problems with the input, with the output. We just work on the algorithm itself. And when it's working, it's plugging into the system, right? Then we are creating an ecosystem, right? All those researchers, all the industry people can work on the same problem, a similar problem together, just like in the CV community and LP community. We are not there yet. We are having private industry academia collaboration, but that's not scalable. It's much better than not having one, but it's not scalable. So yeah, that's my proposal, and I'm trying to do this in my next year's competition, live AIOps competition, test bed. I'm hoping that more and more people, both industry and the community, can join force and collaborate, and especially industry people. We really need the industry people to donate real large-scale software. Okay, thank you.
Oh, very great work. Yeah. So Regita, I think you have maybe only 1 minute. Yeah, because we need the last minute
that's fine. Yeah. So I think Dan said it very well, and there are other questions also. Just one comment I had is in terms of conferences having industry tracks. So for instance, BLDP has an industry track, but it's rather separate from the rest of the conference. So I was thinking if there was some intermingling, that would be good. NSDI, for instance, has this operational track for paper submissions, but they get melded in with the other papers as well. So I think that is another interesting thing that we could do.
Okay, thank you. I think we managed the time very well. We have 1 minute left. can use this 1 minute to end our panel and thank all the panelists. I think we have done a very good job, and all of us have shared very valuable experience and opinions on the topic. So thank you all. Thank you all for sharing your experience. Yeah, for taking your time for this panel. Thank you.
Yeah, thank you. Yeah, thank you, Xin, as
Thank
well.
you.
Thank you,
Yeah,
Jing.
bye.
Thanks.
Very much.
Bye.
Thank you.
Bye.
Thank you. Bye-bye.
Bye bye.
Bye.
Oh, great work. Thank you, guys.
Thank you, Professor Xin. Thank you, Professor Cao.
Thank you. Thank you.
Yeah, thank you very much. It was great work. Bye-bye.
Really
Bye bye.
interesting.
Bye bye.
Yeah.